So let's go back to this example. So here you are shown 10 documents in the training phase, and this is a spam classification problem. This is a simple spam classification problem where there are only two classes. Either a document is a spam document or it's not a spam document. And you need to build a simple classifier to detect a spam document. So let's say in your training phase you're shown 10 documents. And so let's assume that your vocabulary is very simple. It just has these 5 words: cheap, buy, banking, dinner, and the. And these are the labels associated with the 10 documents. These are the class labels. And this particular table also shows which term, which word is present in which document. So document ID 1, for example, only has the word the, and it's not a spam document. Document ID 2 has the words cheap, banking, and the, and it's a spam document, and so on. So obviously in a real example, your vocabulary will be much larger and it will be more meaningful, because you may think, what is this document which only has the word the and it has no other word. But this is just a toy example, so let's just go with this. Now let's say that you are given a test document which says buy cheap dinner. Okay, so this is the test document. So this is the document D. And you want to classify this as either spam or not spam. So you would need to compute two probabilities overall. You would need to compute that this particular document D was generated by the class spam. So what is the probability given this document that it came from the spam class? That's one probability you have to compute. And what is the probability that given this document it came from the non-spam class? So this particular, let's take the first probability. This would be the probability of D given spam multiplied by the probability of spam, the prior probability of the spam class, divided by the probability of the document. This one would be the probability of D given not spam multiplied by the probability of not spam divided by the probability of the document. And again, we can just ignore the denominator, which is the same in both, because it's the relative values of these two that matter. Which of them is larger? That's all that matters. Now what is the prior probability of the spam class and the not spam class? Look at this table. What is the prior probability of spam and not spam?
So spam is 0.3 and not spam is 0.7.
Yeah, because 3 of the 10 documents are spam and 7 of them are not spam. So this value is 0.3 and this value is 0.7. So note that there are two things that are important. When you see a test document, there are two probabilities that are important. First is, so if you are very likely to find documents of one particular class than another, then this particular probability will be sort of biased towards that particular class, which tends to be most frequent, right? So the not spam class tends to be more frequent than the spam class. So among these two terms, you can see that this one is the larger, and that's reasonable because we have to take into account the prior probabilities of documents coming from different classes. But we also have to take into account that given a particular document in a particular class, what is the probability of seeing these exact terms that we see in the test document? That is also important. So both are important. So how would we compute the probability of D given spam? This would be, so what is D? It has these three words. So what is the probability? So we'll use the naive assumption and we'll say this is equal to probability of buy given spam. So D is the vector buy cheap dinner. So this would be P of buy given spam multiplied by P of cheap given spam multiplied by the probability of dinner given spam multiplied by, so going back to the vocabulary, we need the probability of seeing exactly these three terms in the document and not seeing the other two. So the other two terms are banking and the. So if you're given a random document from the spam class, it should have these three terms and it should not have the term banking. So not banking given spam and not the given spam. Okay, so this obviously is just 1 minus the probability of seeing the word banking in a random document of the spam class, and likewise this is 1 minus the probability of seeing the word the in the spam class. Now it turns out that if you look at this table, the appears in every single document, right? So the probability of seeing the word the is 1 irrespective of whether you look at a random document from the spam class or the not spam class. And so this value would be 0. Okay, and that is why we did something called, we looked at something called smoothing, right? Because smoothing is a simple manipulation that we do to prevent any of these terms from being 0, because if even one of these terms is a 0, then the entire expression will become a 0. So we have to account for the possibility that we have not seen, or that we have seen only a representative sample of documents from a particular class. We have not exhaustively seen every possible document that can come from that class, right? So it's possible just by chance that in the training data that we were shown, some words did not appear in any of the documents, or some word appeared in every single one of those documents. This does not mean that the word that we never saw in the training phase can never appear in a class. And it also does not mean that just because a word appeared in every single document of the training phase that it must appear in in every other document. And if it doesn't appear, then it's not, doesn't belong to that class. That would be a very radical step to do. Okay, so we do something called smoothing, where um, instead of just estimating these probabilities as, you know, some numerator divided by some denominator, we saw, for example, that the numerator would be the number of documents which contain the number of documents from the spam class. So if you looking at this particular term, for example, the numerator would be the number of documents from the spam class which have the word by, divided by the total number of documents in the spam class. Now this particular numerator and the denominator would not exactly be what I just described. You may want to add a 1 to both the numerator and the denominator. This is going to ensure that this fraction can never be 0. Now obviously there are different ways to do this. One is to add a 1 to the numerator and to add um, add another number, so let me just call it alpha, to the denominator, where alpha could be just the number of classes. Okay, so the number of classes is 2 here. Or alpha could be the number of terms in the vocabulary, the size of the vocabulary set V. There are different ways to do smoothing, and again you have to see um, which of them turns out to be empirically better. But if we put alpha equal to the size of V, what we are imagining is that before we look at any of the training examples, we are going to assign to each class a document that contains every single word in the vocabulary. Okay, so every class will start from that base document. So imagine that the first training example for every class is a document containing every word in the vocabulary. Then you can look at the actual training data, and then so if you visualize your training phase to be that, then however many number of times you actually see the word by in the spam class, you'll add a 1 to it, because this corresponds to the base document. Okay, so alpha equal to 1, for example, would be so the total number of documents in that particular class we saw was the actual number of documents plus 1. Okay, so this is called add 1 smoothing, where we just add a 1 to the numerator and denominator by imagining this hypothetical document, this hypothetical base document that is associated with every class. Okay, so the total number of documents in the class spam would be the actual number of documents plus 1, and the number of times the word by appears would be the actual number of times it appears plus 1, because it does appear in this hypothetical document. And there are other ways to do smoothing, but if you do smoothing, then your values will be non-zero. Of course, here this is to prevent any of the frequencies from actually being 0. You also have to prevent them from exactly being equal to 1, right? And the way you would do that is to ensure that this value, that the denominator is always more than the numerator. If you ensure that the denominator is all, if a word appears in every single document, then this numerator will be equal to this denominator, right? Because every time you see a document from the class C, you also saw that word. But if you add a larger smoothing factor to the denominator than to the numerator, then this value will not be 0. So you can set the value of the denominator in a bunch of ways. As I said, you could have just taken it as the number of classes, which is 2. Okay, that's one heuristic that's used. So I won't go through the actual numerical values, but I hope you understand now how you would calculate this, and you will calculate the other probability, the probability of seeing the same document in the not spam class in exactly the same way. And you will see which of the two values is larger. If this is larger, we'll say that D belongs to the spam class. If this one is larger, we'll say that D belongs to the not spam class. So this is the worked out example. Any questions about this?
So like, could you please explain the basic thing of smoothing, in the denominator, how exactly in this plus one case, how would it work? Let's say if there's a class which does not have any documents assigned to them at all, so the numerator will also be 1 and denominator would also be 1. So how would
so
it work?
if a class does not have any documents assigned to it, then that's not a good training phase. We are assuming here that in the training phase you are shown at least some examples of documents in every class. If you're not shown any examples of documents in a particular class C, then you can't run this kind of an algorithm, because there's nothing to learn for the machine, right? It won't remain a supervised learning. algorithm anymore if you're only shown examples of some classes but not others, because then you have no idea what to expect from those unknown classes. So there must be some examples you are shown from every class so that you learn at least something about every class.
Okay, sir. And sir, will adding this factor, change the like relative positions, uh, the relative probabilities, like, or will it be the same relatively?
Well, you mean that if this guy is greater than this guy, then
Yes, sir.
can smoothing invert the
Yes, sir.
probabilities?
Yes. Yes, sir.
Um, so I don't exactly know. I mean, intuitively it doesn't seem like it, but there are some paradoxes in mathematics. I think there's a paradox called the Simpson's paradox, um, which actually, if I remember correctly, it has a case similar to what you're asking about. Um, anyway, I don't want to spend time on that here because I don't exactly remember this. But do look up Simpson's paradox. Theoretically, it may be possible, assuming that Simpson's paradox is describing this kind of an example. But usually, this is not something you would expect. Otherwise, this smoothing wouldn't work. With the very fact that this kind of a smoothing is used, add one smoothing, and there are some other forms of smoothing that are uh, that have more complicated formulas that are described in the chapter. This is chapter 13 of your book. So again, what matters is not whether this guy is greater than this guy or not. See, at the end of the day, what matters is whether the relative values of this and this remain the same or not. This and the other value. Okay, that's all we care about. Okay, if whether this number remains less than this number, um, I guess that's not as important as whether this number and this number when combined with other terms give a value that is still less than the values that you obtain from the other product. Oops. Do you see my point?
Yes, sir.
It's similar to the point about not caring about the absolute values of the right hand side, but more about the relative values. So the relative values that matter here are between the entire expression here and the entire expression here. We are not that concerned about the relative values between this and this. There is a slight difference, and if this kind of smoothing slightly changes it. And firstly, I don't think that it's going to change it because you're still adding one to the numerator and a large number to the denominator. Uh, I think, if I remember correctly, Simpson's paradox is about a more general case of this, whereas this is a more specific case. So I don't expect. But again, I don't have a definite answer to your question here right now. So let me look it up and I'll get back to you by the next class. Any other questions?
Sir.
Yeah.
So, actually, no, sir. No, sir. Thanks.
Okay.
So, can we take a 5-minute break, please?
Yeah. Yeah. So we finished the first version of naive Bayes. So after the break, we'll look at the second version. Okay. So who was the person who asked that question about the relative values of these two
Sir,
terms?
sir. Yes, sir. I'm here, sir.
Okay.
Aditya.
Yeah, Aditya. So I just thought about your question, and I think we can prove mathematically that smoothing is not going to make a difference, and it's actually relatively simple to show. So suppose that uh, the numerator is x and the denominator is y. Okay. for this. So without smoothing, okay, let's just look at what the actual values of the numerator and the denominator are without smoothing. So let's say the values are x and y here.
Yes, sir.
The numerator here, let's call the numerator for this term as z. Okay, the denominator will have to be the same, right? Because they are both from the same class, so the number of documents in the spam class is equal to y, right? So this will be x by y, this will be z by y in general, right?
Okay, so z would be y minus x. No, sorry.
No,
X
x,
plus z
y,
is.
and so all that we know is that, so we go back to, okay, so let's say the first, so for the probability of by given spam is x by y. Then the claim is that the probability of any other word given spam will be, the numerator will be different because the number of times this word appears in the documents that are marked as spam could be different from x, right? It could be less than x, it could be more than x. But the denominator will have to be the same, because what is the denominator? The denominator is the total number of documents in the spam class that you see in the training phase, right? Is that clear?
No, sir. Like, it's not. I didn't get it, sir.
Okay, so we are looking at the case without smoothing. Okay, so this is case 1. We still have to look at case 2. So case 1 is, let's say we don't do smoothing, and in that circumstance, how do we estimate this probability? We are going to look at the documents that are marked as spam in the training phase. You agree with that? In order to estimate this?
Okay, okay, sir. Like, probability by given.
So how do you estimate this probability? This is the number of times by appears in a spam document divided by the total number of the total number of documents marked spam, right?
Yes, sir.
This is this is how we estimate. This is the maximum likelihood estimate of this probability based on the training data, right? So what I'm saying
Yes.
is, let this be x and let this be y. Okay. Now if you look at some other word, let's say you look at dinner given spam, the numerator may be different for this term, right? Because this would be the number of times dinner appears in a spam document. So that will have to be denoted by a separate variable z. Z will probably not be equal to x. We don't know if it will be less than x or greater than x. But in general, it won't be equal to x. Do you agree with that?
So yeah, so I guess. I mean, but so what if they're equally likely? Like, in that case, it may be equal, right?
Yeah. I mean, there is a theoretical possibility that they could be equal. But I'm saying that in general, there's no guarantee that they'll be equal. So let's just call it by a different variable z.
Okay, sir.
Okay. But what I'm saying is that the denominator will be the same even for the estimate here, because you're
Yes,
looking at
sir.
the same class. So the denominator will have to be y. Okay.
Yes, sir. What is?
So let's say that without smoothing, without loss of generalization, suppose this is less than this. Okay.
Yes, sir.
That means x is less than z. Okay.
Yes, sir.
Then what happens if we do smoothing?
We'll
If
have
we
x
do
plus 1, sir.
smoothing, so this will be x plus 1 divided by y plus some alpha, right? Where alpha could be 1, it could be more than 1, let's not worry about that.
Yes, sir.
And we want to compare this with z plus 1 divided by y plus alpha,
Yes, sir.
right? Now again, the denominators are the same. And
Yes,
if you
sir.
look at the numerator, this is x plus 1 and this is z plus 1. So
Yes,
if
sir.
x is less than z, then x plus 1 will continue to be less than z plus 1.
Yes, sir. Hmm.
So that means smoothing is not going to change anything.
Yes, sir.
In fact, you can also show the following, that not only will it not change the relative values of this term and this term, it will also not change the relative value of this term and dinner given not spam. Okay, let's say this was x divided by y. If you look at this particular probability without smoothing, let's call it a divided by b. Okay, now the denominator may also not be the same because now you're looking at a different class. So let's say that x divided by y is less than a divided by b. Okay, this is without smoothing. We can prove formally that x plus 1 divided by y plus alpha will continue to be less than a plus 1 divided by b plus alpha. Right? That is, if x divided by y is less than a divided by b, we can actually show that this term will be less than this term. And how do we show that? Let's say we cross multiply. If x by y is less than a by b, that means bx is less than ay. Right? I'm just taking b on the other side and y on the other side. Right? If x by y is less than a by b, because all these are
Yes,
positive
sir.
numbers, so bx will be less than ay. Now, if we want to show that this term is less than this term, so how do we show that? Again, we cross multiply. So we want to show that bx plus b plus alpha x plus bx plus b plus alpha x plus alpha is less than um, ay plus y plus a alpha plus alpha. Okay, so this is what we want to show. So alpha and alpha cancel out, and so this would be bx is less than ay. Okay, since you didn't ask this question, let's forget about it for a moment. I can get back to you on that later on.
So,
I thought this would be easy to prove, but I think this will be more complicated. But I think your question was about these two terms, and at least we've been able to show that smoothing is not going to make any difference,
yes,
right?
sir. Yes, sir.
Okay. So let's go ahead with the other model.